good?
Yeah.
Okay, the hinge theorem. So we have the hinge theorem and we have the converse of the hinge theorem. It is very wordy, but it's not a complex idea. So if you read this, let me kind of break this down for you and use this picture to make sure it makes sense. So the first part says if two sides of one triangle are congruent to two sides of another triangle. So we're using two triangles here. Looking at my picture, one side congruent, another side congruent. That has to be there in order to use the hinge theorem. That's your first sentence, or first part of it. Two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger to the included angle of the second. Included angle you should be somewhat familiar with from our, I forget what chapter it was, with congruent triangles. So the included angle is the angle that's sandwiched between those two sides that are congruent. So this pink is the included angle. And it's saying the included angle of the first is bigger than the included angle of the second. So you can see that this angle is 88 degrees, this angle is 35 degrees. Clearly this one is bigger than this one. It's the included angle that's bigger. Then the third side of the first is larger than the third side of the second. This blue down here is your third side. Congruent, congruent, included angle. What it tells us is this included angle is bigger than this one, which tells us this side is bigger than this side. So this is really wordy, but that's what it means. So a hinge theorem, again, you have to have two sets of congruent sides. This angle is bigger than this angle, so this side is bigger than this side. So that's our regular hinge theorem. Our converse says the exact opposite because we know converse is switching the hypothesis and the conclusion. This one says, and I'm picking apart what's written up here, if two sides of one triangle is congruent to two sides of another. Congruent, congruent. And the third side of the first triangle is longer than the third side of the second. So here's our congruent sides. That's my third side. And if you look at my picture, this 12 is obviously bigger than 9. So since 12 is bigger than 9, therefore the included angle of the first is larger than the included angle of the second. So because this third side is bigger than this third side, this angle must be bigger than this angle. So kind of recapping. Two congruent sides. This angle is bigger than this angle, so this side is bigger than this side. For the converse, two sets of congruent sides. This side is bigger than this side, so this angle is bigger than this angle. Do you guys hear that converse in there? Okay, let's look at some examples. Okay, the directions say complete with greater than, less than, or equal to. The first example in blue. Remember, to use the hinge theorem, we have to have two sets of congruent sides. These are marked as congruent. These are marked as congruent. This is my included angle. So this angle is what we're going to pay attention to. We need to compare which one's bigger or smaller. FG, this one here, or LN. So what can we say? You know, we can use the hinge theorem because we have two sets of congruent sides. These angles are the same. So what do you think is going to happen with these third sides? What would be your guess? They're going to be equal. Kind of takes it a step further. They're going to have to be equal because if those angles are equal, then that third side is going to be equal. Look at the next example. So I'm looking to see if I can use my hinge theorem. I have a congruent side, congruent side. These angles right here are the included angles that I need to pay attention to. These are names. That's not 1 degrees and 2 degrees. So these are names, and that's what we're comparing. So I'm going to look at the third side. Here's my third side. Which of these is bigger? The 8 or the 7? The 8. Okay, so since this side is bigger, that means this angle will be bigger. So they have congruent sides, two sets of congruent. This side is bigger than this side, so this angle has to be bigger than this angle. You guys see that? Okay. Next example, do we have two sets of congruent sides? No. We do. These are marked, and remember, with a lot of problems in geometry, not everything is spelled out for you. You have to know that this side here is reflexive, which means it's congruent to itself. So I do have two sets of congruent sides. This angle and this angle is my included angle, or kind of my sandwiched angle, which means I can use that opposite, that third side is what I can compare using those angles. So 98 is bigger than 95. So which of these third sides, this side or this side, is going to be bigger? Which is going to be bigger? Well, LS. This angle is bigger than this one, so this third side, LS, is bigger than that side, MS. The next section takes it a little bit further. It says, write an inequality using the hinge theorem to describe the restrictions of X. Remember some of the problems that we did last time were very similar. It said describe. That means that there's going to be more than one possible answer. So looking at my first example, in order to use the hinge theorem, you have to look at those two congruent sides first. So I see these two 6s are the same, and I know that they're congruent. I know this middle line is reflexive, very similar to the last problem that we just did. So these two angles right here, this angle and this angle, are the ones I need to pay attention to. Those are the included angles. So what can I say about these third sides? Just in very general terms, what can I say? Which one's bigger? So we have in two sets of congruent sides. This angle is bigger than this angle, which means this side is bigger than this side. So that's informal. Let's just change it to formal. That means X is bigger than 7. Look at the next one. So you always want to start with those congruent sides. I see that these two sides are congruent. That middle one is reflexive. So concentrate on those angles that are included. For this triangle, this angle right here is the one that's included, the one that's sandwiched between the two congruent sides. For this triangle, here's my congruent sides. This is my angle that's included. So the sides that I want to pay attention to are directly across, that third side. So being that 38 is bigger than 30, that tells me that this side is bigger than this side. Let me say that again. 38 is bigger than 30. So this side, 12x minus 7, is bigger than 3x plus 2. So I'm going to set up my inequality that way. Is bigger or is larger than 3x plus 2. We always want to simplify, don't leave it that way. This is actually what pre-algebra is doing right now. So what's my first step in getting x by itself? What do I do first? Move my 3x over. When I do that, I get 9x minus 7 is greater than 2. What's my next step? Add 7 to both sides. And my last step, I'm going to divide both sides by 9, and I get x is greater than 1. So this is my restrictions. X can be anything bigger than 1. One last problem. So I see my two sides that are 45s are congruent. Same thing as what we talked about. This is my reflexive side. Don't know anything about these angles, so I'm going to look at those third sides. 39 is bigger than 36. So going backwards, the included angle, this angle is going to be bigger than this angle. So we have two sets of congruent sides. This third side is bigger than this third side, so this angle has to be bigger than this angle. So 52 has to be larger than x plus 18. And then of course we want to simplify. What's 52 minus 18? 34. I can flip this around, to flip it, just flip everything. Whoops. This is an okay answer. Either of these would work. Homework is posted over here. I'm also going to talk to you guys about recommendations before I give you homework time. So just copy down the homework and then just hold on for a second.